Good morning, everybody. Really excited to be here. I'm Sreeram, founder of EigenCloud. So, what I'm going to talk about today is our new progress into the agentic era. So, the talk is titled Verifiable Cloud for the Agentic Era. Really excited to come speak about this here at Token. So, before we go into the new things that we're doing at EigenCloud, I'm going to start with some numbers, right? So, we raised, EigenCloud raised like 250 million total, 170 million from Andreessen Horowitz, $20 billion plus of each stake. It's the number one US protocol by TVL. So, hundreds of developers building really interesting new services on top. The fastest growing developer ecosystem in 2024, number one DA protocol, a huge and thriving ecosystem. $500 million plus raised by the ecosystem, really valuable. Okay, so this is what we've done till now. What are we doing next? And what's our vision? And why are we doing this? So this is our recent data. When you think about crypto is about building unstoppable, verifiable applications. So you think of Bitcoin. What did Bitcoin do? Bitcoin is an unstoppable money, right? It runs forever. There's only 21 million Bitcoins and you own your coin. So it created this $2 trillion asset. And when you think about what has happened beyond that, Ethereum created this unstoppable verifiable computer, and a computer in which you can deploy programs, and these programs run continuously. So next era, I think what happened is these things got scaled more, right? Solana, for example, took this and scaled it up to say, you can run finance at the speed of light. Okay, so this is how we see the evolution, but underpinning it is the scale of compute. So you look at Bitcoin, Bitcoin can run on a $5 compute. Ethereum sits in a $500 laptop. Solana runs on a $10,000 server. Same thing with other L2s. But to actually realize the full potential of crypto, we need much, much more. We need to be able to fit massively multiplayer games on chain. We need to be able to fit AI agents that you cannot run on any single chain today. We need to be able to fit Uber, the Airbnb, OpenAI, and AWS into these chains. How do we do it? That's our vision at EigenCloud. You should be able to run billions of dollars of compute to run any application imaginable on the verifiable, unstoppable rails. So that's our goal at EigenCloud. Millions of AI agents holding tens of trillions of dollars. That's what we're targeting. Okay, how do we get there? Okay, so this is the vision. How do we actually get there? So we think about it. EigenCloud is not an L1 or an L2 or an app. What is it? The third thing, it basically allows infinite scale computation off-chain, but with smart contract scale verifiability. So you run the application logic off-chain, and you can actually bring those results back on-chain securely. And when you run a computation off-chain, how do you know the computation ran correctly? If you're just going to run it on Google and then bring the results on-chain, that's not interesting. It's neither unstoppable nor verifiable. So when you think about the grades of verifiability, we have many different ways. You can just write the application fully on-chain, and that's going to make it verifiable. But writing it fully on-chain constrains you massively. You're constrained by the virtual machine. You're constrained by the programming environment. You're constrained by the hardware. You have lots of constraints. So you have basically this set of trade-off between what you can do on the cloud, fully programmable, highly expressive, to what you can do on-chain. And there are all kinds of trade-offs in the middle. And what we do at EigenCloud is let you choose your own trade-off. You can actually find you want to run like a hardware security or crypto economic security or a ZK-based security. You can actually choose which point in the trade-offs you want to operate on. Okay, so computation runs off-chain, and then the results are brought in verifiably on-chain. So that's the basic premise of EigenCloud. So how do we actually arrive at this? How do we get these properties? How do we get to cloud scale, where you can scale computation infinitely while maintaining crypto-grade trust? Because if we lose the second aspect, then we don't really get the properties. So the way it works is you think of on Ethereum, on any chain, you can have the staking contracts, and EigenLayer lets anybody stake and run computation. Like I pointed out earlier, we have tens of billions of dollars of stake. So you stake on EigenLayer, and then you can run EigenCompute. EigenCompute is a container standard where you can just like take a container, deploy it to EigenCompute, it runs verifiably and brings the results. So the node is running EigenCompute, and what it also does, it archives the snapshots into EigenDA. EigenDA is a data availability network. You think of it as a storage network, where you can probably retrieve data from it. So you throw the snapshots into EigenDA, decentralized network. The node running EigenCompute may be centralized. There's a single node running it. Okay, so the node runs it, and the node brings state back on chain, where you can actually take actions on chain. Okay, so a single node stakes, running the computation, writing the data to DA, and then brings these results back on chain. Now, you can actually take lots of interesting application patterns where you run the computation off chain and then take actions on chain. I'll give many examples later. But what happens if this single node is a single point of failure if it goes out? Okay, this node is gone now. What happens is, first on EigenLayer, you have this thing called slashing. Slashing means if a node misbehaves, then it's going to lose its stake. So that's why we have tens of billions of dollars of stake on EigenLayer. Okay, so it's going to lose its stake, so it gets slashed. But just slashing it imposes penalties for misbehavior, but doesn't make the system unstoppable. It is stoppable. You just need to pay your slashing penalty and you can stop the system. But what we do is any other node can come in and stake and pick up the computation from where it was left off. So what you do is you go and retrieve the data from EigenDA, and then you can actually continue on and run EigenCompute from then on. So the key thing to observe here, if it's all too technical, is to abstract out. You have EigenLayer for staking, EigenDA for data availability, EigenCompute for computation. These three interlock to produce unstoppable verifiable compute at cloud scale. Why do I say cloud scale? It keeps stretching. The amount of computation available keeps stretching because anybody can come and stake and provide compute and keep running. We already have hundreds of operators, billions of dollars of stake. Okay, so that's the goal of EigenCloud. So in this slide, I'm comparing EigenCloud to an existing Web 2 cloud. How are these two things related and how do they interact? So at the base layer of a regular cloud is a data center, right? So you have Amazon or Google. At the base layer is a data center. And the data center is where everything else is built on top of. A data center is centralized and non-verifiable. At the base layer of EigenCloud is EigenLayer. EigenLayer is decentralized and verifiable. You have nodes that come in. Anybody can come in and stake and run operators and keep the system going. So that's the first thing. The analogy to a data center is EigenLayer. Then you go to a cloud, you don't just get like dark metal data centers. You also get a set of very useful services. Storage, computation, AI being the top three services. You want to store data, you want to do computation, you want to have intelligence. And so those are the three services that are available, the most popular services on top of an Amazon Web Services. That's exactly the three things that we are building on top of EigenLayer. EigenDA for data availability, EigenCompute for computation, and EigenAI for AI inference. So building, I mentioned earlier about how EigenCompute works in terms of running off-chain compute and bringing the results back on-chain. The same thing is true for EigenAI. You want to run AI inference off-chain and bring the results back on-chain verifiably. And so when you think about running AI off-chain, one of the biggest constraints, biggest problems is AI is non-deterministic. If you run the same, if you ask ChatGPT the same question a couple of times, you get a different answer. And the reason it's non-deterministic, the surface level, there's a thing called a random seed. There's a randomizer that actually is applied at the beginning. But even if you control the random seed, you use the same seed again and again, you will not get the same answer. It's because there's all kinds of non-determinism in how a GPU works, how it's scheduled, how the key value cache works, and all these things. What we have done at Eigen is to control this end-to-end. So you get a fully deterministic AI stack. So that's what EigenAI is, fully deterministic AI made verifiable because you have the stake and operator backing it. So EigenCloud comprised of EigenLayer, decentralized verifiable network at the base, services like EigenDA, EigenCompute, EigenAI built on top, which are first-party services that we've built. And there is a thriving ecosystem of AVSs built on top. What is it similar to? In the cloud, you have this whole set of applications they call software as a service, right? Software as a service solutions that actually provide useful and interesting services, whether it's running a database, whether it's running an authorization, whether it's payments via Stripe or PayPal. And so you have these software as a service solutions built on top. The same thing on EigenCloud is these AVSs, autonomous verifiable services, and we have a whole suite of them, each of which specialize in some kind of verifiable task. So if you look at in the cloud era, the software as a service was one of the most profitable sectors. We expect in a similar way, there will be highly specialized, purposeful AVSs built on top of Eigen. And finally, applications can mix and match these services and produce highly expressive, very useful applications at the end. Today in crypto, people talk a lot about, are all the applications going to completely internalize the infrastructure? So if you rewinded back to 1998 or 2000 on the web applications, you will see a similar debate. People will say, should every application should run its own servers? And it turns out that's absolutely not what happened. Netflix, the largest internet consumer, still runs on the cloud. Netflix, the largest internet consumer, still runs on the cloud. It's because it's super hard to build and scale these things correctly. We believe the same thing will be true for crypto. So we are building for a third thesis of crypto other than the app chain thesis or the big chain thesis. It's the cloud thesis of crypto. Okay, so Eigen's already the category leader in restaking, it's category leader in DA. We created the category of AVSs and also category leader there. What we're doing next is launching compute and AI. Last night, Singapore time, EigenCompute and EigenAI launched on mainnet Alpha, which is a first version of our mainnet. And both of these services are now available to be used. So really excited to see what developers are going to cook up. Okay, what is our bet? What are developers actually going to cook up? So if the talk till now was technical and it's zoned out, it's time to zone back in. I'm going to talk about applications. What can you do with this? What are the new and exciting things that can be built on top of Eigen? So first one, Agentic finance, right? So if you look at, crypto today, one of the biggest unlock was the automated market maker, Uniswap, launched with, where you can just go and provide liquidity passively. We believe the same thing is going to happen, but at a much bigger scale because of AI trading agents, where you can give money to the agent and the agent actually goes and does actions on your behalf. So we don't think this is a purely crypto trend. It's going to be a big deal even outside crypto. Why is it? If you think of a machine learning model or a chatbot like Grok or ChatGPT, they don't want to necessarily integrate agentic trading there because this is a huge liability. Imagine Grok goes and buys Dogecoin on your behalf, and then you may be aggrieved that, Doge went down. So you have a big problem there where when you're running these agents, you need to give different kinds of guarantees. Our vision is we will guarantee that this particular agent code can only operate your money. This is a very different kind of guarantee. But what you're guaranteeing is that this agent code runs and trades your money. And so this can actually move liability out of us or anybody who's building this to say, you know the code, you decide whether to use it. Exactly what Ethereum does for smart contracts. Okay, so that's what we envision. Anybody can come provide liquidity or to give the money into a vault and the agent can go and do the trades. But end-to-end, the agent is verifiable and unstoppable. Runs on its own, runs forever. So we did a recent partnership with Google Cloud to actually accelerate their agentic payments protocol. You tell an agent, hey, go do these things, and there's a manifest and a rule that you can actually communicate to it. But how do you hold it accountable? How do you hold it trustworthy? That's what you can do on top of EigenCloud. Okay, so that's agents, right? the other thing, so the easy thing to think about when you think about EigenCloud is, if you had infinite scale computation, what could you do, in a verifiable, unstoppable way? Crypto gaming was supposed to be a big, a direction, and I don't think it has happened yet. What was originally envisioned. Uh, the one thing that we found actually as a really interesting use case is running gaming tournaments. So imagine you are a non-crypto game, right? It's basically, we have this partner called OpenFront, which is a battle royale game, which is not at all built for crypto rails. It's actually, massively multiplayer game. 400 players can play this simultaneously. And you want to run tournaments on top of this game. Anybody can come in and put like $100 and say, hey, I'm participating in this game tournament. Whoever wins the tournament is going to get $50,000. And so you want to build these kinds of tournaments. You can build the tournament like financial logic on chain, but the game itself runs off chain, but verifiably. So you get the superpower. In fact, it's a new business model for games. Instead of, just selling subscription or selling game assets, you can actually build games with inbuilt markets. So that's another thing we're very excited about, on that. Okay, the next application, social media, right? So, one of the things, so this is an altercation between Elon Musk and Sam Altman, right? They're both, saying that, hey, Twitter is rigged, it's favoring Elon, or, the App Store is rigged, it's favoring ChatGPT. So what do? Can you actually solve this problem by having verifiable feeds, verifiable ranking? You can actually do this on top of EigenCloud. Anytime you want to do a computation, you want to know that the computation happened exactly as stated, you can go launch it on EigenCloud. And so we have a launch partner called OpenRank, which is actually building, verifiable seeds. When you look at your seed on, the app is called Cura. When you look at your seed on Cura, you know that this recommendation algorithm ran and produced my results. The results were not manipulated. There is no reordering. There is no, attention hijacking going on. So what else? Agentic governance. So when you think about like what's going on in crypto, how do you actually solve governance? If somebody comes and contributes to the EigenLayer protocol with new code base, how do we value and, give them, tokens and rewards? How do you do this in, you can think of it in a big brain open source funding way, or you can think of it on a degen meme coin way. You have a meme coin and a meme coin wants to say, whoever is helping spread the meme coin, they should get more tokens. So what you can do is you can actually write an AI agent and hook the AI agent to have mint rights for your token, which means it can create new tokens out of, your token contract. It's a highly trust sensitive position to say, oh, this particular agent can mint tokens. It better be verifiable. It better be trustworthy. That's exactly what you can do on EigenCloud. You can build extremely interesting new applications, which is simply impossible before. Have an AI agent crawl your Twitter, crawl the GitHub, see what contributions you made, and then reward you accordingly. We had a demo app called Vibe Score, which scores, how vibey you are, and in a verifiable manner. Okay, so finally, I think this is the biggest one, sovereign agents. So, Satya, the Microsoft CEO, was asked on a podcast, do you think AI is a new kind of life? Is it a new species? And I said, no, it doesn't have property, cannot own property, an AI agent. An AI agent cannot take liabilities, cannot enter into contracts, cannot start companies. They can't do any of these things because our legal system doesn't allow it to do it. But this is exactly what blockchains were designed for. Any program can actually own property on top of blockchains. And with EigenCloud, you can actually make AI agents just like smart contracts. What this does is suddenly you can build fully sovereign, highly expressive AI agents, but the agent is its own person. It's not working for you or working for me. It's working for itself. So this is a shift in the paradigm, and we're very excited to push this frontier ahead. Really excited to be here. Thank you all for attending my talk.